In previous videos, I used IEEE spanning tree protocol, which is common spanning tree protocol. And one of the problems that we had was we couldn't have fast convergence. For any change in the network, we had to wait something at least 30 seconds so that the network is going to be stable again. Now, we have solved some of the problems by just configuring the access ports as port fast, but we cannot really do this on trunk ports. So what I'm going to do is to change the type of protocol that I'm going to use. And for this, I had to remove all the configuration that I had before. And I'm going to do the configuration again, but I'm just doing it on one or two of the switches, and I'm going to show you what the configuration should look like, because I have to go with VNC connection again. And in this case, you can see that it is a little small. And if I try to make it bigger, for example, if I just say scale the window and scaling by 2, you can see that what is going to happen is it doesn't really show a lot. So if I just try to increase the size, you can see that the connection is going to be kind of broken. So I have to go back to my older setting. So I'm not going to scale the window. I'm just trying to connect one more time. And just close this and click on this so that I see the connection one more time. And then I just have to go with this. I have removed bridge 1 by just typing no bridge 1 and then commit. When you do this, all the configuration that is kind of related to bridge 1 is going to be removed. But anyway, we can just go with different types of protocol that have the mechanism of proposal and agreement, which is going to give us much faster convergence in the network. So let's just do this. I'm going to say OcNOS for the username and password. Then I'm going to go to configuration mode. And if I just do show run, you can see that for now, I don't really have any connection configuration on the interfaces. So what I'm going to do is to say bridge 1, and I should have this here. Kind of lost the configuration. Okay, bridge 1. One more time. Let me just do start it again and bring it here. Okay, this is better. Bridge 1 protocol, and you can see that there are multiple types of protocol that I can use. The most important one is going to be MSTP, or multiple spanning tree protocol, which is the most scalable one, and I'm going to use this. But you can go with RSCP, which is rapid spanning tree protocol, and RPBSC plus, which is kind of a Cisco thing, but it is implemented in here. That is a premium version of RSCP with some more features. And the good thing about these two is both of them have a fast convergence, something kind of in a 1 or 2 seconds. MSTP uses the same configuration that RSCP has, but MSTP has another feature which I'm going to speak about in a second. And let me say what is the configuration that we have. So let's say that in IEEE, in RPBSC, or in RSCP, we have something like 50 different VLANs. So these VLANs are going to be active on all of these trunk ports. The thing is, we have just decided that switch 6 is going to be the root bridge for us. But what I mean, or switch 5 maybe, is going to be the root bridge, and switch 6 is going to be the backup root bridge. What I mean by that is, all of the devices connecting to root bridge, the ports that are connected to root bridge, they are going to be configured as root port, and the rest of the ports are going to be blocked. For example, in switch 3, this link is going to be root bridge, and this link is going to be blocked. This is root bridge, and this one is going to be blocked. This is root bridge, and this one is going to be blocked. And the same thing here. This is going to be blocked, and this is going to be the root bridge. I don't really want to have this kind of a configuration because I have paid for these links. I want to make sure that all of these links are available and usable. So what I'm going to do is to go with another kind of configuration. I would say, for example, I'm going to have VLAN 10, 20, and 30. and VLAN 40, 50, and 999 in my network. And of course, this can go, this can become a very long list, because we basically are trying to just divide the VLANs into the number of links that we have here. I'm going to say switch 5 is going to be root bridge for 10, 20, and 30. And switch 6 is going to be root bridge for 40, 50, and 999. This means that for this 40, 50, and 999, I'm going to have this active and this one as blocked. But for 10, 20, 30, this is going to be blocked and this is going to be active. This means that now my links are utilized completely without any problem. And in case one of the root bridges go down, the other root bridge is going to take over, because I am going to configure this root bridge to have more priority over 10, 20, 30, less priority over 40, 50, and 999, and exactly the opposite of that on this one, on switch 6. So what I'm doing here is to just make sure that all of the links are going to be useful for me. Now, the problem is each one of these VLANs are going to be are going to have their own spanning tree, and each one of those trees are going to be calculated for me. So here I have 6 VLANs, then 6 instances of a spanning tree protocol should be run in my network, so that they can get what exactly we want to have in our network, which link is going to be blocked for one of the VLANs, which link is going to be forwarding for the other VLANs. The thing is, we have only 2 links. Why should I run 6 times just to decide which link is going to be forwarding and which link is going to be in blocking state? I'm going to do something else. So I'm going to say, okay, this group of VLANs are going to use the same tree. So I'm going to say this is group number 1. This group of VLANs are going to use another tree. So they are going to be group number 2. If I have 3 links, then I would create 3 different groups. If I had 4 links, then I would create 4 different groups. But I have 2 links for each one of the access links, so I go with just 2 groups. And then I would say just run the spanning tree protocol once, not 3 times. And if I had, for example, 25 VLANs, then I would have to run it for 25 different instances. But here I'm saying for all these 25 VLANs, for example, I have, you just run this protocol only once and compute the tree only once. So this means that a huge burden is going to be lifted on from the switches. Switches are going to be used more effective, and the RAM and CPU is not going to be utilized so much. So this is what multiple spanning tree means. Multiple spanning tree says, I'm using the fast convergence features of RSCP, but I'm just using 2 or 3 instances or a few more instances for a lot of VLANs that I have here. This means that I am more effective. And if I just want to add more VLANs, that's so easy. I can just add it to this instance or to this instance, and then everything is going to be just fine. I'm going to be using the most effective, the most scalable type of spanning tree protocol that I can. So the configuration of MST is something that I really need to do on these switches. So let's start with doing this on switch 1. This is switch 1. And first of all, I would say bridge 1 protocol is going to be MSTP, and hit enter. And then I need to configure this MSTP. So first of all, I'm going to say VLAN database, because I have lost all my VLANs now. I'm going to say VLAN 10 bridge 1, state is enable. And then I'm going to create VLAN 20, VLAN 30, VLAN 40, 50, and 999. So 999. So far I'm going to commit everything. If I say do show bridge, for now you can see that it says the bridge is running on MSTP, and I have some VLANs, of course. If I just say do show VLAN brief, it says that I have these VLANs created. Now what I'm going to do is to say that these VLANs should be categorized in different instances. I'm going to create only 2 instances, and that's going to be quite enough. I have only 2 links. So first of all, I would say spanning tree MST configuration and hit enter. Now you can see that I am under MST configuration. So I'm going to say bridge 1, this is the one that I have created, is going to have instance number 1, and it's going to have VLAN 10, 20, and 30. Then I'm going to say bridge 1, instance 2 is going to have VLAN 40, 50, and 999, and hit enter. So these 2 have been configured for me, so I'm going to just say commit for now. So far I have no problem. Okay, now that I have created this, what I'm going to do is to say my trunk links, which are on switch 1, Ethernet 7, and Ethernet 1, run both instances. Why both? Because I want to make sure that in case one of the switches, which is the root switch, in case that goes down, the other one is going to take over. So I'm going to run both of them at the same time on all the interfaces, but which one is going to be blocked, which one is going to be in forwarding mode, the switches are going to decide about that. So let's do that. I'm going to say interface ETH1. So I'm going to say bridge group 1, and then say instance 1. Okay. Instead of just saying bridge 1, now I'm going to say bridge group 1, instance 1. And I remember that if I just say do show run interface ETH1, you can see that ETH1 has lost all its configuration. So what I'm going to do is to say this is switch port mode is trunk. That's it. And I'm going to do the same thing on Ethernet 7, interface ETH7, switch port, bridge group 1, instance 1, and I forgot to add instance 2 to Ethernet 1. I'm going to do the same thing right now. So here, instance 2 is going to be added to here. Switch port mode is trunk, and that's almost this. Let's go back to interface ETH1. I'm going to say bridge 1, instance 2 as well. So if I just say do show configuration or show configuration, so configuration, do show configuration. Yeah, it doesn't go with. That's okay. Let's commit the configuration that we have. And here we have some problems. It says I should say show configuration, show transaction. Of course, not show configuration. Sorry, I should say show transaction current. And here it says that we have interface Ethernet 1, bridge group 1, instance 1, then switch port mode trunk, and interface Ethernet 7 has the same thing. And I just went back to interface Ethernet 1 and did this. So what is the problem that says here? We have a failed configuration, and it says that network instance is a problem under interface. So we have Ethernet 1, Ethernet 7. So let's just do this right now. Abort transaction. Do show bridge says that we have this bridge. Do show MSTP configuration, or do show run. Let's go to here. we have our MSC configuration, which is okay. Okay, so very nice. So what I'm going to do is to say interface ETH1, switch port, bridge 1, instance 1, and bridge 1, instance 2. So let's commit this configuration for now. And it says that I cannot configure this because of the instances. Maybe import transaction again. Let's do this. Interface ETH1, switch port, commit, bridge group 1, instance 1, and that's it. Commit. And here we have a problem with instance. So what is the problem? It says that the interface is not in trunk mode. Maybe that's the problem. So if I just say abort trend to show run interface ETH1, for now it says just switch port. Interface ETH1, switch port mode is trunk. And I'm going to say commit, and we should go with something like that. Bridge port group 1. So if I just say commit, then bridge group 1, instance 1, then I'm going to commit. Now there is no problem because we had to have this bridge group 1 first and then go with these two instances. And now commit. Okay, to show run interface ETH1. So this is the configuration that we have right now. We need to make sure that this is part of the bridge group, and after that configure this as different instances. So I'm going to go to interface ETH7 and do the same thing here. So I'm going to say switch port, bridge group 1, and then I'm going to say switch port mode, of course, is trunk, then bridge group 1, instance 1, and also bridge group 1, instance 2, and then commit the configuration. Okay, now we have no problem doing this configuration. So I'm going to do the same thing on other switches. So let's just open an instance of Notepad, and on this write the configuration that we had. So the first thing that we did is this. I'm going to just go back to here and say to show run. Okay, so what I'm going to do is say bridge 1 protocol MSTP, and then I have VLAN database, bridge 1, not bridge 1 of course, VLAN 10, bridge 1 state is enable. I'm going to copy this, and this should be 20, 30, 40, 50, 999. And then I'm going to go with the spanning tree configuration. So I'm going to say exit, spanning tree MST configuration. Then I'm going to say bridge 1 instance 1, VLAN 10, 20, 30, and also bridge 1 instance 2, VLAN 40, 50, 999. And then I'm going to exit. Next is going to be interface configuration. I'm going to go with interface. What are the interfaces that we have here? Ethernet 1 and 3 on all of these switches. Ethernet 1 and 3. So I'm going to say interface ETH1, switch port, bridge group 1, switch port mode trunk, and bridge 1 instance 1 and bridge 1 instance 2. So the same thing is going to happen for Ethernet 7. So I'm going to say interface Ethernet 3, sorry. And all of them should be done. And of course I need to do some commits here. First commit should go here. Then I need to commit here. And maybe I need to commit here. And finally I need to commit here. So basically this is the configuration, and I'm going to enable this on all switches, and then I'm going to go back here. Okay, now I am connected through secure CRT again, and I'm going to show you some configuration that I have not shown you before. These are very important. Right now I am on switch 1. Switch 1 has a connection to my jump box, which is on VLAN 999, and that is very important. I'm going to say show run interface ETH5. Now you can see that here I have just gone through the configuration like what I have done on common spanning tree configuration. I have switch port and considered bridge group 1 on that. Mode is access, and switch port access VLAN is 999. Now VLAN 999 was part of instance 2 in my MSC configuration. So at least I should say bridge group 1 instance 2, because this is important. I have added bridge group 1 instance 1 command as well. So this is not necessary. As a matter of fact, you shouldn't really have this here. I just added for the sake of simplicity. And finally, I could have configured edge port, but instead of that, I said port fast. So if I say show spanning tree here, it will say right now, if I just check here, it says that the instance root, which path cost is 0, and root port is 3, which is going to be port 3, I guess. And CISC bridge port priority is this one. We have not changed it. The delay, hello time, max stage, and stuff like that, all of them are the same. But like I said, this multiple spanning tree doesn't really go with these timers. It just has its own proposal and agreement, let's say, mechanism that it uses. So the bridge ID for now is F001, and the root is F201. But for each port, of course, you can see some different information, which is interesting. So here it says Ethernet 1 is port 3. Here you saw that the root was available on port 3 here. The root was available on port 3. So this means that for this one, for Ethernet 1, the root is going to be available on ETH1 for which is switch 6 actually here. So checking more information, it's going to give you this one that says version multiple spanning tree protocol, and I am sending and receiving MSTP information, but I have not configured BPDU guard and stuff like that. But here it says that port fast is off on Ethernet 1. The only configuration that I have for port fast is on Ethernet 5. So if I just go down on Ethernet 5, it says that there should be somewhere that says port fast is enabled here. Yes, port fast is configured on this Ethernet 5. And again, Ethernet 5 says it is port number 7. That's okay. And the port ID and some designated bridge and root bridge, it doesn't really matter, because on port Ethernet 5 I don't really care about the stuff like that. On Ethernet 7 is going to be important for me. So if I just go down here, it says that the designated bridge is going to be F801, which should be, I guess, switch 5. So based on the VLANs that we have, that's going to be different. The other command that I'm going to check is show bridge. So on show bridge, of course, like I said, this is not going to show you some good amount of information, unfortunately, but the first part is going to be important. Bridge 1 is running on MSTP, and that is what we have. And we have not configured VXLAN or stuff like that. So if I just go with show bridge, I'm going to say 1, and after that, I just hit enter. That's going to say incomplete command, although it says you can hit enter here. That's funny. And so what I'm going to say is show bridge 1, and that's going to be MSTP show bridge 1 MSTP. For some reason this is not showing. Show bridge 1 spanning tree, and this is path because I'm not going to go with this. Show bridge MSTP and hit enter. That's going to give you more information about MSTP instance that is running under show bridge. And the other thing that you have is show MSTP MSTP. It is not part of that. That's okay. Show spanning tree MST. Now we can have configuration. Checking configuration, you can see some information about configuration, but we are going to go with more detail of configuration. So I'm going to go with MST detail here and hit enter. That's going to give you full information about all of these, and on each one of them it says that which instance is running here. Instance 1 is separate from instance 2. So you can see that this gives you more information specifically about the role of each interfaces, which is very important to understand. So most likely the role is going to be either alternate or designated. Designated means that it is right now forwarding, but alternate means that it is not forwarding, it is just waiting for the designated port to be shut down or have a problem so that it takes over. So you can see that for instance 1, it says that Ethernet 1 is alternate, and this means that the other interface, which is going to be Ethernet 7, is going to be in forwarding mode for instance 1. So if I just go to Ethernet 7, it says that this is root port and is in forwarding state. That is exactly what we have in our topology. So I have configured this. The other thing that I need to show you is how I configured switch 5 and switch 6 as root bridges. I have two different instances of VLANs. For one of them, for one group of VLANs, switch 5 is going to be root. For one instance, switch 6 is going to be root. And I have configured them in a way that switch 6 is going to be backup for instance 1, root for instance 2, and switch 5 is backup for instance 2, root for instance 1. I'm going to show you the command. Instead of using bridge 1 priority, I have used bridge 1 instance 1 priority. So let me show run, and let me hit enter, and here are the commands. You can see that for both of them I have configured the priority. On switch 5 I have decided that instance 1 is going to have this bridge as root. Instance 2 is not going to be the root on this, but if for some reason switch 6 goes down, this is going to take over. And the same thing of course is configured here. So show run, here it is. You can see that for instance 2 now this is the root, and for instance 1 this is backup root based on the priority that I have set on these switches. So this is very important to understand. One more time, something that is very important to understand is I have configured, let me show run interface, let's say 8.1. On all trunk interfaces, I just made sure that switch port trunk allowed VLAN all is configured, because I considered this to be the default, but obviously this is not the default. The default is no VLAN is allowed on this. So what if you do not configure this? Then your VLAN interfaces are not going to be up and running. They are going to be up down. This means that physical is going to be up, but protocol is going to be down, which is stopping them from acting normally. But as you can see, I have connectivity from my jump box to all of these switches, which means that everything is working just fine. Okay, so this is almost all about spanning tree, and in the next video I'm going to continue.